So this is a video for the worksheet for the section 4.9 on the Pythagorean Theorem. And we have 8 questions, so let's get through them one at a time. Number 1 and 2, you're asked to find the missing side, and they already have the Pythagorean Theorem for you. They have everything plugged in, because if you remember, the Pythagorean Theorem is a squared plus b squared equals to c squared. They already plugged in the numbers for a and b, and the only side that doesn't have a number is the missing side, c. So all you have to do is crunch your numbers and get the answer. So can someone tell me what's 4 to the second power? 4 times 4, which is 16. Can someone tell me what is 5 to the second power? 5 times 5 is 25. And all of this has to equal to the second power of c, or c squared. Alright, perfect. Now we just need to add these two. What's 16 plus 25? 41. And that equals to c squared. Now I don't really need c squared. I need c. So can someone tell me how I can isolate c so it's just c and nothing else? If you say take the radical of the second power of the c to the second power, you're absolutely correct, because they're opposites. Radicals and powers are opposites. So I'm going to do that. I'm going to take the radical. It was very pretty, and remember, if there's nothing there, we automatically assume it's a radical of the second power. So we take the radical of the second power, but we also have to do that for both sides. On here, the right side, the radical and the exponent cancel each other out, they're opposites. So you're left with just a c. Exactly what we're looking for. Is 41 a perfect square? It's not. 41 is not a perfect square. So you have to estimate your root. Can someone tell me what are the two closest roots, one below, one above, for 41 that we can use? The one below it is 36. The one right above it is 49. And what are the square root answers for 36 and 49? For 36 it's 6, because 6 times 6 gives you 36. And 49 it's 7, because 7 times 7 gives you 49. Of course you could have had the negative 6 and negative 7 as well. We're talking about measurements here, and you can't have negative measurements, so we're going to keep it to the principal roots, the positive ones. So since 41 is somewhere in the middle, what should my answer be? 6.5 would be a good estimate. And that's all I really want from you, is an estimate. So that's the answer. C is approximately 6.5. Makes sense. It's got to be the longest side, and 6.5 is longer than 5 or 4. Questions on number 1? Alright, number 2 works out in a very similar fashion to number 1. Can someone tell me what's 7 to the second power? 7 times 7 is indeed 49. What about 2 to the second power? 4. 2 times 2. All of that has to equal out to c squared. The sum of these, what's 49 plus 4? 53. Is 53 a perfect square? It's not. So in order to get rid of this power of 2, I do need to take the radical of the second power of both sides, just like I did last time. But 53 is not a perfect square. So can someone tell me what are the two closest perfect squares to 53? One above, one below. Well, 49 is right below, and right above 53 is going to be 64. And what are the square root answers, or the root answers, for 49 and 64? For 49 it's 7, just like it was here, 7 times 7. For 64 it's 8, 8 times 8. And again, we're keeping to the principal roots or the positive roots. So up top, the radical of the second power and the exponent cancel each other out. So we were left with just C. And here, 53, the answer is going to be right in between 7 and 8. So what's in between 7 and 8? Seven and a half? Yeah. Sounds about right. And that's an estimate for number 2. And once again, 7.5 is longer, not by much, but it is longer than all the other sides. So that also makes sense to me. Any questions on 2? Alright, for number 3, you were supposed to find the missing side, just like before, but they haven't plugged them into the Pythagorean Theorem. So you have to first state with the Pythagorean Theorem. So what is the Pythagorean Theorem? A squared plus b squared, I used green last time, equals to c squared. Now fortunately we know what a is. What's a? A is the shortest side, 4. What's b? B is that middle side. And of course c is the missing one. So what's my next step? What should I do next? Substitute. Plug them in. For a it's going to be 4, so instead of a squared it's going to be 4 squared. For b it's going to be the 8, so it's going to be 8 squared. And of course I'm still missing my c, so that's just going to stay a c squared. What's 4 to the second power? 4 times 4, 16. What's a to the second power? 64, 8 times 8. What's the sum of the two? What's 16 plus 64? 80. Now, 80 is not a perfect square, unfortunately. So when I try to get rid of this power of 2 by taking the radical on both sides, 80 doesn't come out nice and neat. I need to estimate it. So what is the two perfect squares above and below 80? Well, the one below it, right below it, is going to be 64. The one right above it is 81. Now I can tell 80 is almost 81, so it's going to be very, very close to what 81 is. And what is the root answer for 81? And 64. Well, for 81 it's 9, or 64 it's 8. So your answer is going to be somewhere in between here, but this time because it's so close to 81, it's definitely going to be closer to 9. So I'm going to say that C is almost 9. You can say 8.5, but it's honestly more like 8.9. If you wrote 8.5 on the quiz, I wouldn't mark you off. But because it's really not in between, it's almost 81, the answer should be almost 9. So 8.9 is almost 9 for me. Questions on number 3? Alright, Let's take a look at number 4, which is on the left side. And here you are also given a triangle with two known sides. In this case, this side is known and this side is known, and one missing side. But the missing side is a short one, it's not the hypotenuse. We have the hypotenuse and the middle side. So the first thing I'm going to do is I'm going to write the Pythagorean theorem. So a squared plus b squared equals to c squared. Alright, that's the Pythagorean theorem. And I don't know what a is, but I know what b and c is. C is the longest side always. And b is that middle side. Now I'm going to plug things in. A I still don't know, but I know B is 11. And I know C, for a change, it's 14. And A just stays behind. Alright. Now I'm going to crunch my numbers and see what I get. A squared obviously stays behind. 11 squared, what's 11 times 11? 121. What's 14 times 14? Anyone? It's 196. So 196. Oops. Clumsy today. Alright. Now what's my next step? Because I want A all alone. What can I do? I can subtract 121 from both sides, right? That is definitely something that I can do and something that I will do because I'm trying to isolate the A. So I'm going to get rid of this 121 from both sides. Alright, on the left side that 121 is gone, leaving me with just the A squared. On the right side, what's 196 minus 121? If you said 75, you're absolutely correct. What's my next step? Get rid of this power of 2 by taking the radical of the second power from each side, finding this square root. Is 75 a perfect square? Fortunately, it is not. So I need to estimate. So 75, what are the two nearest perfect squares to 75? Well, the larger one is 81. The smaller one is 64. And what are the square roots of 64 and 81? 9 for 81, 9 times 9, 8 for 64, 8 times 8. So my answer is going to be, it's pretty much right in between the two, so it's going to be between 8 and 9. What's between 8 and 9? 8.5. Sounds good to me. So my answer is about approximately 8.5. Makes sense. A should be the shortest side, and it's definitely shorter than the other two. So questions on number 4. For problem number 5, you're given three sides, and you're asked to figure out if the sides make up a right triangle or not. So the first thing you want to do is write up the Pythagorean theorem. A squared plus b squared, and of course equals to c squared. then you have to make sure that you plug in the right sides into the Pythagorean theorem. So what should I assign 5, 6, and 9? Which letters are 5, 6, and 9? Well, for me, the shortest one is always A. The middle one is B. And the longest one is C. And my next step is just to plug them in and see if it works or not. If it does, it's a right triangle. If not, then it doesn't work. So instead of A, I'm going to write 5 squared. Instead of B, I'm going to write 8 squared. And instead of C, I'm going to write 9 squared. Alright, so far so good. Now just crunch my numbers. What's 5 to the second power? 5 times 5 is indeed 25. What's 8 to the second power? 8 times 8 is 64. And what's 9 to the second power? 81. 9 times 9. Now, can someone tell me what is 25 plus 64? If you said 89, you're absolutely correct. So 89 does not equal to 81. They're not the same. Quite obvious there. So this is not a right triangle. Does not pass the Pythagorean theorem. So nope. Questions on 5? Let's take a look at number 6 then. Same deal. You write out your Pythagorean theorem. And then you assign your numbers. What should I assign my letters to for the sides? I'm going to pick A to be the shortest, B to be the second shortest, and C to be the longest. C always has to be the longest. The other two, you can change them around, although I prefer A to be the shortest side. And then you plug them in. Instead of A, you have 8 squared. Instead of B, you have 15 squared. Instead of C, you have 17 squared. And what is 8 squared? 64. What about 15 squared? 225. And what about 17 squared? What is 17 times 17? You guys have 289? That's awesome, because that's exactly what it is. Alright, and now for the final part, the two shorter sides, do their areas or their squares equal out to the longest side square? So it's 64 plus 225 give us 289? And the answer to that is yes. It's a perfect match, and that means the theorem works. This is indeed a right triangle. Questions on number 6? Let's do the last two problems, number 7 and 8. For number 7, you're given a triangle and you're given some squares that could result from each side. So from this side you can get that square, from that side you can get that square, and from the large side you can get that large square. And first of all, they're asking you several things. What are the two legs? What are the two legs of this triangle? The shortest leg right here is 5. The other leg is 7. It's the second shortest leg, or the second longest leg, or it's the longest leg, I suppose. And what's the hypotenuse, or the longest side? It's right there, it's the 10. Okay, that's good so far. Then they're asking for the areas of the legs. They want you to find the area of this leg, or the area of the square that this leg makes. And then of course they want you to tell them what is the area that's formed by the other square as well. So how do we find the area of this square and that square? Well, it's a square, so you multiply one side against another, and since they're all the same, it doesn't really matter. So for the smallest one, it's 5 times 5, which is 25. It's kind of small to see, sorry. And for the other one, it's 7 times 7, which equals out to 49. So the two areas are 49 and 25. I'm going to write them up here. So that one ends up being 25, and this one ends up being 49. Now they're asking you to add them together. Well, so what's the sum of the two? What's the sum of 25 and 49? $74. If you and me got our math correct. And it makes sense to me. Alright, now what about the hypotenuse? What's the area of the triangle formed by the hypotenuse? It's 100. 10 times 10. So this particular triangle, or fictional triangle, whatever you want to think about it, has an area of 100. Now next they're asking you, what is the relationship between the sum of the area of the legs and of the hypotenuse? So what do you think the relationship is? Well, I would say that the relationship between the two is that they're not the same. The sum of the areas for the legs was 74. The hypotenuse is 100. So the relationship is that they're not the same. The areas are not the same. And since they don't have the same areas, the last question says, is this the right triangle? Is it? No, it's most definitely not a right triangle. So this one is not a right triangle. Not a right triangle. Questions on number 7? Alright, number 8 works out in a very similar fashion. Once again, can someone list me the two legs of this triangle in question? 5, the shortest leg, and 7, the long leg. And what's the hypotenuse? What's the longest side of this triangle? $13, right there. Alright, now what are the two areas formed by the two legs? So they're asking you for this square right here and this square right here. What are the areas of these two squares? Well, for the smaller one, it's 5 times 5, which gives us 25, similar to the last triangle. For the slightly longer one, we have 12 times 12, which of course gives us what? If you said 144, I totally agree with you. So this one right here is 144. This one is 25. And now we're going to add them together. What's the sum between the two? What's 144 plus 25? 169? Yep. Alright, what is the area of the large triangle that's formed by the hypotenuse? I couldn't even fit the entire triangle on my paper, but it would be up there. So it's 13 times 13, which gives us 169. Now the question comes in, what is the relationship between the areas of the legs and the hypotenuse? Anyone have an answer for that? I would say that they're the same. The relationship is that they're identical. 169 for both, which means, is this a right triangle or not? It is indeed a right triangle. And that's that. That concludes that problem too. Any questions on number 8? All right, thank you very much.